Saturn is the sixth furthest planet from our Sun. It is the second largest planet in our solar system and one of four gas giants. Saturn is home to 53 confirmed moons and 9 provisional moons. Saturn is about 891 million miles from our Sun, or about 79 light minutes, as compared to Earth, which is only 8 light minutes from the Sun. Saturn was named after the Roman god of agriculture and wealth. Just 10.7 hours compared to 24 hours on Earth. The days on Saturn may be short, but the years are very long. The planet takes 29 Earth years to complete one revolution around the Sun. Saturn's magnetic field is smaller than Jupiter's, but 578 times as powerful as Earth's. Saturn, the rings, and many of the satellites lie totally within its enormous magnetosphere. The magnetosphere is the region of space in which the behavior of electrically charged particles is no longer influenced by solar winds, but instead by the planet's. Aurora occur when charged particles spiral into a planet's atmosphere along magnetic field lines. These bright auroras occur around Saturn's poles but are not visible to the human eye, as they mostly shine in ultraviolet and infrared light. On Earth, these auroras are caused by charged particles that come from the solar wind. The Cassini spacecraft has shown that at least some of Saturn's aurora are like Jupiter's and are largely unaffected by the solar wind. Instead, these auroras are caused by particles ejected from Saturn's moons and the magnetic field's rapid rotation. These non-solar originating auroras are not entirely understood yet. There have been several missions to explore Saturn in the past years. The first flyby of Saturn was performed by the Pioneer 11 spacecraft in 1979. The next two flybys were from Voyager 1 and 2 in 1980 and 1981, respectively. The most famous mission is definitely the Cassini spacecraft, which has been actively studying the planet since its arrival in 2004. As of November 2016, Cassini has entered its final stages of exploration. On September 15, 2017, Cassini will plunge into the planet to avoid biologically contaminating, potentially habitable moons. Saturn gets its tan color from ammonia crystals in the upper atmosphere. Saturn is covered with clouds, stripes, and storms. The winds in Saturn's upper atmosphere can reach speeds of up to 500 meters per second, as compared to the strongest hurricane winds on Earth that top out at around 110 meters per second. Saturn has an interesting atmospheric feature that was discovered in 1981. The Voyager spacecraft first discovered the 20,000-mile-wide hexagonal storm with a massive rotating storm at the center. There is no other feature like it elsewhere in the solar system. As a gas giant, Saturn doesn't have a true surface. The planet is mostly swirling gases and liquids with an iron, nickel, and rock core. While a spacecraft would have nowhere to land on the planet, it wouldn't be able to fly through it either. The extreme pressures, temperatures, and winds deep inside the planet would crush, melt, and vaporize a metal spacecraft trying to fly through.
Saturn's largest moon, Titan, is the second largest moon in our solar system, second to only Jupiter's Ganymede, which is only 2% larger. It has a mean radius of 1,600 miles and is bigger than Earth's moon, and even larger than the planet Mercury. Titan's the only moon in our solar system that has clouds and a dense atmosphere, composed of mostly nitrogen and methane. It's the only place in the solar system known to have an Earth-like cycle of liquids flowing on its surface. Titan was discovered on the 25th of March in 1655 by the Dutch astronomer Christian Huygens. Titan orbits Saturn at a distance of about 760,000 miles, taking 15 days and 22 hours to complete a full orbit. Titan's tidally locked in synchronous rotation with Saturn and permanently presents one face to the planet as it completes its orbit. Titan is surrounded by an orange haze that kept its surface a mystery for Earth scientists until the arrival of the Cassini mission. Titan's atmosphere extends about 370 miles high, making it a lot higher than Earth's atmosphere. Some of the compounds produced by the splitting and recycling of methane and nitrogen in the upper atmosphere create a kind of smog, a thick orange-colored haze that obscures the moon's surface from view. Because the atmosphere is so high, Titan was thought to be the largest moon in the solar system for a long time. It wasn't until 1980 that Voyager was close enough to discover that it was actually smaller than Ganymede. Titan is the only moon in the solar system with a thick atmosphere. Its atmospheric pressure is about 60% greater than Earth's, roughly the same pressure found at the bottom of a swimming pool. Because Titan is less massive than Earth, its gravity doesn't hold on to its gaseous envelope as tightly, so the atmosphere extends to an altitude 10 times higher than Earth's, nearly 370 miles into space. Titan's atmosphere is mostly nitrogen, about 95%, and methane, about 5%, with small amounts of other carbon-rich compounds. High in the atmosphere, methane and nitrogen molecules are split apart by the sun's ultraviolet light, and high-energy particles accelerated by Saturn's magnetic field. The products of this splitting recombine to form a variety of organic molecules. One of Titan's great mysteries is the source of its methane, which makes all of this complex chemistry possible. Since sunlight breaks down methane in the atmosphere, there has to be a source that replenishes what's lost. Researchers suspect methane could be belched into Titan's atmosphere by cryovolcanism, or volcanoes with water as lava. Cassini revealed that Titan's surface is shaped by rivers and lakes of liquid ethane and methane. These liquids form clouds from which the liquid gases sometimes rain from the sky, as water does on Earth. Titan, being negative 290 degrees Fahrenheit, is so cold that water plays the role of rock and lava, and flowing methane carves river channels and fills lakes with liquid natural gas. Large regions of tall dunes stretch across the landscape. Titan has a few impact craters, meaning that its surface must be relatively young, and some combination of processes erases evidence of impacts. This is the case for Earth as well. Craters on our planet are eroded by the relentless forces of flowing water. These forces are present on Titan as well. Tectonic forces, the movement of the ground due to pressures from beneath, also appear to be at work on Saturn's largest moon. An awesome fact about Titan is that its thick atmosphere, low gravity, which is less than our moon, and reasonable surface pressure, being 50% of Earth's, mean that by flapping a pair of wings strapped to your arms, you could fly in its skies with no more effort than walking.
Alright, hey, I'm Chris, and I'm here to talk about the sixth largest moon of Saturn, and it is Enceladus. So, I'm going to talk about the basic features of Enceladus, how it was discovered, who discovered it, and the geographical features of it. I'm also going to talk about the ocean that lies beneath Enceladus's crust. Alright, so Enceladus's basic features has a radius of 157 miles. Its gravity is 0.113. And once you think about that, it's like Earth has a gravitational force of like 9.8. So you'd be getting up there. It has an orbital period of 33 hours. Its distance to Earth is 790 million miles, and its density is 1.61. Enceladus is also Saturn's sixth largest moon. So it was first discovered in 1789 by William Herschel. He used his 1.2 meter telescope to observe it. Little was known until Voyager spacecraft, which was in like the 1980s. And it was named after the giant Enceladus of Greek mythology. So here's some geographics of it. Enceladus has a wide range of surface features, ranging from old, heavily centered regions to young, tectonically formed terrains, which was formed at least 1,000,000 years ago, 100 million years ago. So, contains a large number of craters, but also has some smooth areas. Voyager 2 was the first spacecraft to observe Enceladus' surface in detail. It observed craters, smooth plains, and rigid terrains bordering the smooth areas. Alright, so here's some stuff about the ocean. Evidence of liquid water on Enceladus began to accumulate in 2005, when scientists observed plumes containing water vapor spewing from its south polar surface. Gravimetric data from Cassini's December 2010 flyby showed that Enceladus likely has a liquid water ocean surface between its frozen. Let's look at some pictures. So this first picture on the left, this is Enceladus, and it shows a great little view of the craters and also some of the tectonic like terrain, as well as some smooth parts which were created by the water eruptions from Enceladus' surface. And And then the next picture is the man himself, William Herschel, who discovered Enceladus. And then here's a picture of the telescope he used to discover it. So in these next pictures is the water eruption from Enceladus, and it shows great flumes, and it just all spews out from the southern poles. And then here's a little graph of Enceladus showing its ice crust, its global ocean, and its rocky core. So all of this spews from Enceladus all occurred on the southern pole. So that's where all the active jets were, and that's how we started to discover that Enceladus had this really huge ocean inside of it.
The rings of Saturn are by far the most extensive planetary ring system of any planet in the solar system. They consist of countless small particles made out of water, ice, or rocky material, which range in size from micrometers to meters. There is no consensus as to the mechanism of the formation of Saturn's rings, but we will have a talk. In 1610, the year after Galileo Galilei first turned a telescope to the sky, he became the first person to observe Saturn's rings, though he could not see them well enough to discern their true nature. In 1655, Christian Huygens was the first person to describe them as a disk surrounding Saturn. Although many people think of Saturn's rings as being made up of a series of tiny ringlets, they actually have true gaps. It is more correct to think of the rings as an annular disk with concentrical local maxima and minima in density and brightness. On a scale, the clumps within the rings, there is much empty space. The densest parts of Saturn's ring systems are the A and B rings, which are separated by the Cassini division, along with the C ring, which was discovered in 1850 and is similar in character to the Cassini division. These regions constitute the main rings. The main rings are denser and contain larger particles than tenuous dusty rings. The latter include the D ring, extending inward to Saturn's cloud tops, the G and E rings, and the others beyond the main ring system. These diffuse rings are characterized as dusty because of the small size of their particles. Their chemical composition is, like the main rings, almost entirely out of water ice. The narrow F ring just off the outer edge of the A ring is more difficult to categorize. Parts of it are very dense, but it also contains a great deal of dust particles.